Look, I was looking at section 14.4. This section, as you can see, talks about expected value. Expected value is a way of using probability to figure out how much you can stand to gain or lose from a situation. So, for example, when we talk about expected value, if quite often it's used in business models, if especially like stock markets, if a particular stock is expected to do well, you measure the probability, and of course there are various ways of finding that. You measure the probability of the option that the stock does do well, compare it with what you stand to gain, versus the probability that it does not do well and what you stand to lose. That's basically what expected value is. Calculating all those probabilities to see what's your best option, all things considered. So expected value, as I said before, we use probabilities to determine what to expect, wins, loss, gains, etc., over a period of time. And as I mentioned before, it's used heavily in business risk. Insurance companies use it tremendously. Obviously, gambling, when it comes to games like poker, of course. Anything card related that involves money is going to weigh heavily around it. Or even games like roulette, if you've played that before, craps, all those revolve around expected value. What you stand to lose versus what you stand to gain. What do you stand a better chance of getting? And so obviously when you talk about expected value, it can be just about any number. And it corresponds to typically like money lost or gained. Obviously the more positive it is, the more you stand to gain from this particular event. The more negative it is, the more you stand to lose from an event. And so a fair game is considered where the expected value is absolute zero. It means there's no, all things considered, on average, you have an equal chance of winning as much as you have equal chance of losing, and then comparable amounts. So let's take a look at some examples of expected value. So here is the basic formula. So the expected value is where you add up. First of all, you figure what's the value of outcome number one, whether it be in dollars or what have you. What's its value? And you took the value in terms of positives and negatives. So if it's a gain, the value is considered positive. If it's a loss, the value is considered negative. You multiply that times the probability of that particular outcome. Then to that you add the product of the value of outcome 2 times the probability of that same outcome, and so on and so forth as many times as needed. So let's look at a few examples. In a raffle of 1,000 people, the grand prize is $1,000, 2 consolation prizes are $500, and the last prize is $100. 3 are awarded total. If the cost is $5 to enter a raffle for each prize, what is the expected value? So when we talk about the expected value, of course we have to consider what we stand to gain versus lose. In this case, it's easier to think of in terms of gaining. So let's look at each of our possibilities. The first possibility is that we win the $1,000, we win the big reward. So that's my first probability over here. Let me move this up here so there's not too much information on the screen. That's 995. Now you wonder why it's not 1,000? That's my value. We want to consider the overall value. I'm taking away $5 because I've paid $5 to enter this contest. So even if I win, I've already lost $5. So I have to take that into account. This, by the way, is one of the reasons if you've ever seen a street grifter or one of the people you see in the street with the card game, the 3 cards, and you try to guess which one it is, this is one of the reasons why those games are almost impossible to win. They're stacked against you, obviously. They're stacked against you such that you have a better chance of losing rather than winning, or the times you do lose, you will lose more than what you would win. So again, $1,000 prize becomes $995, and if there are 1,000 people, of course, there's 1 out of 1,000. There's 2 consolation prizes at $500. So again, if I were to win, I would have stand to made $495. The probability being 2 out of 1,000. The final prize is $100. 3 of which are awarded, so my overall value would be 95 if I were to win that, times 3 over 1,000, the probability that I get that. Now we also have to consider the possibility that we, of course, don't win anything. The fact that, obviously the bigger chance that I lose money. And so that's my overall expected value then is minus 5, because then I pay my $5, I don't get anything back. The chances of that are, if there are 6 possibilities to win, then there are 994 possibilities to lose. So these are the fractions that I set up, and then it's just a matter of doing the math. So here they all are. So my expected value is negative 2.7. So that means I stand to lose on average, were I to play this game, 100 times or so, I lose about $2.70 each time I play it, on average. So, the more I play it, the more chances I have to lose it. I basically lose more than I would win. And this is what expected value is. And here again, expected value is just another way of showing why lotteries are it's so rare to win them, and why it's, I wouldn't say it's hopeless. It's obviously you can win, but the numbers show it's just very, very difficult, especially considering what you put in, that you make it back up when your chances are so slim. Let's look at another example. A service that repairs air conditioners sells a maintenance agreement for $80 per year. The average cost of repairing an air conditioner unit is $350, and 1 out of every 100 people will require repairs. What is the expected profit for the maintenance agreement? So basically, the business has to figure out if they get a maintenance agreement for $80 a year. The average cost of repairing an air conditioner is $350. There's a 1 out of 100 chance that any unit will require repairs. So we have to compare that against the $80 a year that they're getting from each customer. So what's the expected profit? So expected profit, expected value, same idea. So again, our profit we have to consider is $80 for this agreement. Again, we're looking at an individual customer. So an individual customer pays $80 for this agreement per year. On average, it costs $350 to repair a cost. Repair one of these air conditioning units if it needs to happen. And again, the probability of that is 1 out of 100. So we say, what's the per year? What do we stand to lose? Well, there's 1 out of 100 chance, and each time that happens, we lose $350. So on average per year, we stand to lose $3.50. Which means when you compare that against the $80 that were paid out, in this case, the profit margin is very good. So because the probability of these machines actually needing a repair is so low, on the off chance that does happen, over a year you stand on average, again, this doesn't mean it's going to happen, but per customer, per year, you stand to lose on average $3.50, which means when they pay $80, you're making a pretty good profit, again, on average. Again, these are used for analysis. This isn't exactly hard black and white numbers that this won't happen. They're used for, again, statistical analysis and just business analysis especially. It's used to help people make an informed decision. Here's a common case. In a liability case, a company can settle out of court for a loss of $350,000 or go to trial, and they stand to lose twice that if the person is found guilty, or if the company is found guilty. And obviously they don't lose anything, disregarding fees and whatnot, if you're found not guilty. So the company's lawyers estimate they have an 80% chance that the company is found not guilty. So what's our expected value should the company go to court? So let's see. We're going to compare. We'll say if we plead guilty, we lose $350,000. So that's just a lump sum. That's just a sum to consider. That's what we're considering. We could lose $350,000 in one way, or we take our chances and go to the courts. Now let's check the expected value. If we win, if you're found not guilty, nothing happens. Lawyers say there's an 80% chance that happens. So, let's use our math. We'll say the probability or the value of being found not guilty. Now, value, now we're considering loss. You have to think of it this way. The value, or what you expect to lose, would be 0. Now, the probability of that is being found not guilty. They say it's an 80% chance, so 0.8. Now, to consider that with the probability that we are found guilty, so that in that sense we stand to lose $700,000. The probability then, of course, of that happening is our complement, so 20% chance. 20% chance to be found guilty. So we want to find what's the overall expected value. Obviously, the first one is going to be 0. And when we do the math, so our overall expected value, if we go to court, stands at negative 140,000. Again, on average, we expect to lose 140,000. So we compare that with what we stand to lose if we don't go to court, 350,000. So this question comes down to not necessarily, it's not so much that of course I want the expected value. Should the company go to court? That's more of an opinion question. That's something you analyze yourself. And a lot of these questions, it's an analysis. It's not necessarily this is a concrete right or wrong answer. It's obviously the expected value is the number that I'm looking for. But sometimes what I'm saying is, like, to answer the second part of that question, should the company go to court? And what I look for on a test or quiz is, what is your opinion based on the numbers? Because oftentimes it's not a clear-cut yes or no. Sometimes it can be questionable. Now this one's a little bit easier, because if we go to court, on average we stand to lose 140,000. Odds are. If we don't go to court, we stand to lose 350,000. So that's a fairly clear-cut decision. I would say the company would say we probably would go to court and take our chances, because odds are we stand to lose less than what we would lose had we just settle. Now again, if you're thinking, well, you still could lose $700,000, and that's true. But again, this number just gives us kind of an analysis, something to compare to. On average, like I said, if we would do it 100 times, we'd probably lose $140,000. So again, it's a comparison. It's just information to help us make a decision. But again, our expected value is negative 140,000. Should we go to court? If it were me, I would say company probably their best bet is to go to court. The odds are, on average, they lose less than if they were just to settle. Now finally, this next one is actually from the book. Have your books on page 701, number 13. This is a good example of another use of expected value. In this case, the expected value isn't so much are you winning or losing a gambling bet, but what do you stand to make? Another way of using expected value. Grace Adler is planning to buy a franchise from Home Depot. I don't know why they still say Home Depot. To sell decorations for the home. Table below shows average weekly profits rounded to the nearest 100 for a number of the current franchises. If she were to buy a franchise, what would her expected weekly profit be? And here it is. I love the recreation. Average weekly profit, and then here on the right, who earned each amount. And again, it comes down to average. So she wants to see if she gets a franchise. Now, one thing this question didn't do is it didn't tell us how much does it cost to invest in the franchise, unless I missed something, and it doesn't look like I did. So we're not even calculating what you pay to have access to the franchise versus what you're profiting. But that's okay. We're just looking at it from the perspective of, we've already bought into it, what do we stand to gain? It's done the same way. We want to see what's the probability that we earn $100 a week but we need a total. And if we add up all the people who have been doing this, who we're considering, that's 50 people. So when we compare each of our probabilities, let me scoot that over. The first value I have, of course, is 100. Again, we're looking at profits, so these are all going to be positive. The probability of me gaining $100 is 4 out of 50 based on the empirical data. Plus the probability of 200, which is 8 out of 50, plus 300 times 13 out of 50, 400, and so on and so forth. Each time the expected value times the probability of that outcome. And when you do the math, you get $328 that you stand to make on average based on this franchise. So again, to answer this question is fairly straightforward. It says if she were to buy a franchise, she could expect her weekly profit to be about $328. Based on the data that's provided her. Again, it's the expected value. Judging by who makes the most, and you have a whole range. It's expected that she makes $328, which makes sense when you look at the numbers. If 13 people made $300, 21 made $400, it stands to reason that the bulk of them made in that range. So it makes sense that she's making around $328. So this is the focus of 14.4. As always, if you have any questions, feel free to contact me, and have a good day.